This question is taken from IBHL Analysis and Approaches sample paper. This question asks you to investigate regular n-sided polygons inscribed and circumscribed in a circle and the perimeter of these as n tends to infinity to make an approximation for pi. So let's start it. So part A says consider an equilateral triangle ABC of side length x units inscribed in a circle of radius 1 unit and center O as shown in the following diagram. The equilateral triangle ABC can be divided into three smaller isosceles triangles. So it's just like that. Let me show it to you. So it can be divided into three smaller triangles like this. And angle is 2 pi by 3 at O. So we can use the concept of symmetry here, since the total angle at O is 2 pi and is symmetric because it's a regular polygon, it's an equilateral triangle. So we can divide the 2 pi by 3 to get the angle at the center. So it's 2 pi by 3 as shown in the second diagram. So in this they said use the right angle trigonometry or otherwise show that the perimeter of the equilateral triangle ABC is equals to 3 root 3. So if we use the right angle concept here, we have to drop a perpendicular from O to the side CB, and we know when we drop a perpendicular is the property of circle that the chord is bisected into two equal parts. So this part is half x and the angle is also bisected. So 2 pi by 3 is bisected, means is pi by 3 now. So we can use this triangle with the angle pi by 3 and the length opposite to it is half x and the radius, which is OC, is 1 unit. So in order to find the length x, we can simply use opposite over hypotenuse, which is sine ratio. So it's sine pi by 3 equals to half x over 1 and the value of sine pi by 3 is root 3 over 2. That's equals to half x. So x is coming under root 3. Since they are talking about the perimeter of this equilateral triangle, the perimeter is supposed to be sum of all the sides of the triangle. So the perimeter will be 3 times of under root 3. That's what you have to show in this part 1 for 3 marks. Now if you look at the part B, it says consider a square of side length x unit inscribed in a circle of radius 1 unit. By dividing inscribed square into 4 isosceles triangle, find exact perimeter of the inscribed square. So in that case, if I just draw it here, so here is my circle and a square is inscribed in it and the length of the square is x. That's what they said. Here is the center O. So you can divide your square into 4 isosceles triangle now, and the radius is still 1 and the angle at center should now be 2 pi over 4. So that's going to be pi by 2 is the right angle triangle already. And now you have to find the perimeter of square. That should be 4 times x, the perimeter. So you have to find the x value. So we can use the Pythagoras theorem here, which is the x square equals to 1 square plus 1 square. So x square is going to be 2 and x is under root 2. That's the value of x. So the perimeter for part B should be 4 times of under root 2. That's the perimeter in part B. So we found the perimeter for equilateral triangle, perimeter for square now, Let's go to the part C now. In part C, they said find the perimeter of a regular hexagon of side length x inscribed in a circle of radius 1 unit. So now they're saying that there's a regular hexagon inscribed in a circle of radius 1. So let's just make this diagram here. So it's a circle, and now the regular hexagon is inscribed in it. It's like this. So with the center we can again divide this hexagon into isosceles triangles, and the angle at center should now be 2 pi divided by 6 since it is symmetric, and the radius is still 1. So when we drop a perpendicular now, so the angle becomes pi by 6 when we divide, since it bisects the angle, bisects the length. So the length x is divided into 2 equal parts, so that's half x, and the angle is going to be pi by 6 now. So if we use the trigonometric ratio again, so it's the opposite, which is the half x over the hypotenuse, and is sine pi by 6 is equals to sine pi by 6, and the sine pi by 6 value is half, so it's half x. So x is going to be 1. So the perimeter of this hexagon is, since there are 6 such lengths, all are equal, so the perimeter is 6 times 1, which is 6. So it's 6 times 1 units. So that's part C. Okay, now they are saying show that so they've written this as PIN is equals to 2n sine pi over n, and this time is the n-sided regular polygon. You can just read this is let PIN represents the perimeter of any n-sided regular polygon inscribed in a circle of radius 1. So this is how they constructed the formula. So in part D you have to use this same method that you have used for equilateral triangle, for square, and for regular hexagon. Same concept. You have to show the perimeter in n, in terms of n. So I'm going to use the same concept here. Let me just draw this triangle now. So I'll be making the triangle directly. So the angle at center now becomes 2 pi over n and the radius is still 1 unit, and if we drop a perpendicular, angle is bisected as well as the length opposite to this vertex. So the length is going to be half x, and the angle is going to be pi by n, angle at